essential pre-flight checklist for your lab. Look, if you operate these analyzers, you already know that precise calibration is the absolute bedrock of reliable environmental data. But let's be honest, flipping through technical documentation can totally pull your focus away from your actual workflow. So we're going to visually break down the manufacturer's exact protocol into a streamlined, super easy to follow process. Let's get right into it. Okay, here is the game plan. We're looking at a 4-step journey to nail down perfect data accuracy. We'll start with the calibration starting line, then move to step 1, setting units. Step 2 covers dilution ratios. Step 3 is all about the span gas. And step 4 brings it home with the actual zero and span calibration. First up, the calibration starting line, where we establish our ground rules. So, your very first rule, straight from the manual, is this. For a first-time startup, you absolutely must use the exact same reporting range setup as the factory calibration. Why? Well, it allows you to accurately compare your fresh, new calibration results directly to the factory settings listed on your final test and validation data sheet. It's basically an essential reality check for your instrument. Oh, and quick side note, if you're reporting separate parameters via analog outputs, like NX-CNC1 and NX-CNC2, you're going to need to perform separate calibrations for each of those using the LO and high buttons. Moving right along to step 1, setting units, which is really about choosing your measurement. Right out of the gate, you've got a crucial choice to make for your concentration units. You're looking at either ppm, parts per million, or mgm, which is milligrams per cubic meter. Now, this might seem like a totally minor detail, but getting this unit right from the very beginning ensures that all your downstream data logging and reporting aligns perfectly with your specific regulatory or lab requirements. You definitely don't want to mix up here. Luckily, navigating the T200H and T200M interface is highly logical. Starting from the main sample display, you just hit Setup. That takes you right to the primary setup menu. From there, select RNG to get to the range control menu and hit Unit. Boom, you're at the Conc Unit screen. It's a super simple toggle. Just press the button to choose either ppm or mgm, lock it in by pressing ENTR, and you are ready to keep moving. All right, step 2, dilution ratios. This is all about adjusting for your specific application. So, if your specific lab application actually involves thinning out the sample gas, and you've got the dilution ratio option enabled, listen up, your measurements will be completely skewed if the machine doesn't actually know the sample has been thinned. To fix this, you just access the DIL factor screen, which you'll find sitting right next to the unit button in the range control menu. Here, you'll just toggle the numbered buttons across the bottom of the display to match your precise dilution ratio factor. Once you've got that number dialed in to reflect your lab setup, you absolutely must press ENTR to accept the new setting. If you press Exit here, it literally just ignores your changes and reverts back, so make sure you lock that in. Hey, taking a quick breather from the technical steps for a second, if you're finding this visual breakdown of the Teledyne nitrogen oxides analyzer helpful for your lab workflows, go ahead and hit that subscribe button. We regularly turn complex technical manuals into clear, visual explainers just like this one, and we would absolutely love to have you join our community. Okay, back to it. Now we're getting into the heavy lifting with step 3, span gas, setting those concentrations. The big thing to remember here is the 80% rule. Your expected NO and NOx span gas concentration should always be set to 80% of the actual range of values you expect to encounter in your specific application. It's brilliant, really, because it optimizes the instrument's accuracy for the actual real-world conditions it'll be measuring, rather than just calibrating to some arbitrary maximum. Now, the default factory setting typically sits around 100 ppm, but you're going to use the menu to dial in your precise 80% target. From the Cal menu, just select Conc to enter the concentration menu, and then pick NOx. From there, you use the toggle buttons to input your exact span gas value. And hey, there is one absolutely vital rule to keep in mind here. If you supply NO span gas to the analyzer as well as NOx, the expected values you enter for both of those gas concentrations must be completely identical. Once they perfectly match what's in your physical gas cylinders, just hit ENTR to accept the settings. And finally, we've reached step 4, the zero/span calibration. I like to call this the waiting game. So looking at the actual calibration flowchart, yeah, it can feel incredibly dense at first glance. It honestly looks a bit intimidating, but I promise it actually boils down to a very methodical sequence driven by the analyzer's test functions. You're basically just cycling through the TST button until you find a specific stability metric, letting the gas flow and pressing a button to tell the machine, hey, this is 0 or this is my span. Let's de-jargon that whole flowchart into 4 simple actions. 1. Introduce the zero gas to the sample port at the back of the analyzer. 2. Wait for the stability reading to drop. 3. Lock in the zero concentration. And 4. Introduce the span gas and literally just repeat that identical process. That's the whole shebang. The entire pacing of this crucial step really relies on one highly specific metric, and that's NOx/STB. By pressing the TST button on your main display, you can cycle through until the screen shows NOx/STB equals. Now, don't brush past this. This isn't just some basic reading. It's a dedicated test function that mathematically calculates the stability of the NO and NOx measurements in real time. It tells you exactly when the gas concentration inside the reaction chamber has completely leveled out. This is where you really just have to embrace the waiting game, allowing the zero gas and later the span gas to enter the analyzer and strictly waiting for that NOx/STB reading to fall below 0.5 ppm is absolutely non-negotiable. The manual explicitly warns that this might take several minutes, so grab a coffee if you need to. Once it drops below that 0.5 threshold, you press 0 to enter the zero concentration menu and press ENTR to change the offset and slope values. When you're doing the span gas, the span key will pop up during the transition. You just follow the exact same rule. Wait for stability below 0.5, hit span, and press ENTR. As you prep your Teledyne T200H or T200M for testing, consider this final thought. Taking the time to let your zero and span baselines truly stabilize isn't just some annoying waiting period cooked up in a manual. It is the absolute, uncompromising foundation of everything you will measure next. If your zero baseline is rushed, is any measurement that follows truly accurate? Every single data point you collect afterward carries that initial error. So respect the NOx/STB reading, follow the steps precisely, and your data will speak for itself. Thanks for joining me for this explainer, and happy calibrating. All right, welcome to this explainer. Today, we're going to demystify the basic O2 sensor calibration procedure for the Teledyne API Model T200H and T200M analyzers. Look, if you're working with these instruments, you already know exactly how critical precise environmental monitoring is, right? But having that O2 sensor option installed, well, that's really only half the battle. Ensuring it is flawlessly calibrated is where the actual precision happens. So we're going to break down the exact Teledyne API protocol to get your analyzer operating at absolute peak accuracy. To get there, we're following a precise 4-step recipe today. First, the calibration setup. Second, setting span gas concentration. Third, activating the stability function. And finally, number 4, the actual zero and span calibration. Let's get into it. Step 1. The calibration setup. First things first, we need to gather our physical ingredients before we even think about touching the analyzer's software menus. Now, to calibrate any instrument accurately, you absolutely need definitive reference points. For this, Teledyne API recommends starting with pure nitrogen as your zero gas. Why nitrogen? Well, because pure nitrogen contains absolutely zero oxygen. It's like a blank canvas, allowing us to establish a perfect, undisputed zero-point baseline for the sensor. Then, for your high concentration point, what we call the span point, you're going to need a very specific span gas mixture, specifically 21% oxygen in nitrogen. This mixture is a real game changer because it gives the sensor the exact high-end reference it needs to accurately calculate the full spectrum of your measurements. It's giving the machine its absolute upper limit. Now, think about the physical flow of these gases. During calibration, the standard source of sample gas is completely removed. Instead, your calibrated nitrogen and your 21% calibrated oxygen are routed right through a 3-way valve. From there, they flow down through a manual control valve and then finally into the sample port on the instrument chassis itself. Oh, and there's a really vital vent path involved here too. That's absolutely crucial to make sure the input isn't pressurized, because if it is, that could literally skew your entire calibration. Nobody wants that. Moving right along to step 2, setting the span gas concentration. All right, as we move into the configuration prep, our very first task is telling the machine exactly what span gas concentration it should expect. And the magic number here? It's 20.8%. This is the default factory setting for the O2 span concentration value. And for good reason, it really closely approximates the actual O2 content of the ambient air we breathe. We absolutely need the software's expectations to perfectly match the physical gas we're feeding it. So navigating the software pathway is pretty straightforward. You'll start from the main sample menu, drop down into cow, and then into setup. From there, you just toggle through until you select gas to cow O2. Once you're inside that O2 menu, you're going to see the O2 span conc setting. Now, if your specific span gas happens to deviate from that default 20.8% we just talked about, this is exactly where you step in and manually toggle the correct concentration using the interface buttons. Let's distill that down into 4 simple, actionable steps you can easily remember. 1. Navigate to the CAL setup menu. 2. Select your gas, which is O2. 3. Verify or toggle your O2 span concentration to that 20.8% mark, or, whatever your specific calibrated gas canister dictates. And 4, this is a big one, always remember to hit ENTR to lock that new setting in. If you accidentally hit exit instead, the machine just ignores your changes and, well, you're right back to square one. Okay, step 3, activating the stability function. Now we tackle the next part of our prep work, which means shifting the stability test function. See, by default, these analyzers are set up to look at NOx concentration. But right now, we need the machine to focus exclusively on the O2 sensor output. To make that happen, we have to navigate through the primary and secondary setup menus. And just a heads up, getting to this specific setting requires a bit of security clearance. You actually have to dive into the secondary setup menu and punch in a passcode. Breaking that interface down to its core actions, once you get that prompt, you're going to enter password 818. That's your key to access the deeper variables. Then you'll page through the options using the next button until you spot the setting that says stable_gas equals NOx. You want to edit this so it reads stable_gas O2. Hit enter to save that configuration and then press exit 3 times to back all the way out to the main sample menu. Boom. Now the brain of your analyzer is officially tuned in to the oxygen sensor. And finally, step 4, zero and span calibration. We've made it to the main event. This is where our physical gas connections and our software configuration finally come together for the actual calibration. As you let that pure zero gas enter the sample port at the rear of the analyzer, you're entering the most critical, yet honestly the most demanding phase of the entire procedure. Patience. Seriously, you cannot rush environmental calibration. While that pure nitrogen is flowing in, you absolutely must keep your eyes on the O2 STB. That's the stability reading on your display. You are waiting for that reading to fall below 0.1%. As the manual explicitly warns, this is a milestone that might actually take several minutes to reach. The analyzer is in the background actively calculating the stability of the measurement, and you literally cannot proceed until it confidently drops below that tiny fraction of a percent. So bringing the whole final sequence together, you'll toggle the TST button until your display shows O2 STB. Allow the zero gas to enter and just wait for that critical drop below 0.1%. Once it hits, navigate to Gas to Cal, O2, hit 0, and press Enter to officially log the zero measurement. Then you seamlessly swap over to your 21% span gas, wait for stability to drop below 0.1% all over again, hit span, and press Enter to calculate your brand new slope. Let's recap that physical and digital sequence so it's crystal clear. First, toggle your view to watch the O2 stability. Second, run your zero gas and wait for that magic sub 0.1% stability mark. Third, lock in the zero calibration by pressing Enter. Fourth, switch the physical valve to run your span gas and wait once more for that sub 0.1% stability. And finally, lock in the span calibration. Throughout this whole process, the analyzer is still doing its background cycle of NOx, NO, NO2, and O2 measurements, but your calibration is intensely focused on dialing in that O2 accuracy alone. Now hold on. Before you walk away thinking the job is totally finished, the manual leaves us with one incredibly vital final note. You have to close the loop. Remember how we used password 818 to change the stability gas setting to O2 earlier? Well, you must reverse that exact process to return your instrument stability test function back to normal NOx monitoring. If you leave it stuck on O2, your standard diagnostics just won't behave the way you expect them to. By strictly following these precise steps, respecting the physical flow of the pneumatic connections, locking in the exact span concentrations, correctly assigning the stability gas, and, maybe most importantly, having the patience to wait for that 0.1% stability, you completely eliminate the guesswork. Your instrument's offset and slope values are now perfectly mapped to physical reality, but it really leaves you to wonder, if being just a fraction of a percent off in calibration can totally skew an entire facility's emissions data, what other instruments in your network might be quietly drifting off baseline right now? Definitely something to think about. Thanks for joining me on this explainer, and hey, happy calibrating.